Hello everyone, my name is K. Srinitya. Today I am going to discuss about error detection codes and number codes in digital system. Introduction to codes. Here, codes. What are codes in number systems? In digital electronics and computer system, codes are special patterns of bits, zeros and ones, used to represent numbers, characters, and instructions. Since computers understood only binary, we often use different coding system to make representation simpler, error-free, and meaningful. Introduction to codes. Codes are used to represent numbers, characters, and data in digital system. Importance. The importance of codes are data representation, error detection during communication, and hardware simplicity. Here, binary code. What are binary code? The definition of binary code is basic representation of numbers using zeros and one. Here binary representation is by using 8421 code like 2 power 0, 2 power 1, 2 power 2, 2 power 3. Here weighted system 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8. Example, decimal number 13 can be represented as in binary 1101. Here 2 power 0, 2 power 1, 2 power 2, 2 power 3. Here 2 power 0 means 1, 2 power 2 means 2, 2 power 2 means 4, 2 power 3 means 8. Here 2 power 4 is not required, so we are using only 4 bits. 2 power 3 means 8. 2 power 2 means 4. 8 plus 4, 12 plus 1, 13. Here decimal number 13 can be represented in binary as 1101. Here the applications of binary code is arithmetic, data storage and computer processing. Here the binary code table. Here decimal numbers are 0 to 7 are listed. Here these numbers can be represented in binary as 0, 0, 0, 0 as 0. Here 1 is represented as 0, 0, 0, 1. 2 is represented as 0, 0, 1, 0. 3 is represented as 0, 0, 1, 1. 4 is represented as 0, 1, 0, 0. 5 is represented as 0, 1, 0, 1. 6 is represented as 0, 1, 1, 0 and 7 is represented as 0, 1, 1, 1. Here the information about binary code. Gray code. What is gray code? Gray code, also called as reflection binary code, is a binary number system where only one bit changes between successive numbers. It is a non-weighted code used mainly in digital systems, error reduction and mechanical position encoders. Why we use gray code? In normal binary counting, many bits can change at once. For example, 3 to 4. Here binary expression as 0, 1, 1 is the representation of 3 and 1, 0, 0 is representation of 4 in binary. But in these 3 digits are changed. But in gray code we only change notice 1 bit. This can cause errors in digital circuits like glitches in mechanical sensors. Gray code solves this by changing only one bit at a time. For example, we take a table. Decimal numbers are 0 to 7. Here binary numbers 0, 0, 0 are we show below. Here gray code. Gray code as represented as, for further information, definition is a binary like code where two successive values differ in only one bit. Property of gray code is it reduces error during transaction. Applications. It is used in Karnaugh map simplification and rotating shaft encoder. Here the table. Here we see briefly. Here binary code. Here one by one we see binary code is changes 2 bits or more than 1 bit. But in gray code only 1 bit change from 1 by 1. Here zeros and from 1 to successive numbers only 1 bit is changes. Between any two successive gray code values only 1 bit changes. Here the conversion of binary sequence versus gray code sequence. Binary to gray code. First keep the MSB most significant bit the same. Each next gray bit is equal to binary bit plus XOR previous binary bit. For example, 1011. Here MSB is 1 is same at MSB position 1. Here the next element is obtained by each next gray bit is obtained by binary bit XOR previous binary bit. Here the example of 1011 binary bit. Here the gray code of binary 1011 is 1110. Here the process. First, keep the MSB same, and next is each next binary bit is equal to previous binary bit XOR gray bit. Applications of gray code. Here rotatory encoders are sensor to avoid misleading positions in digital communication, reduces error changes. Karnaugh map simplification of Boolean expressions, error minimization, ensures only one bit transition. X3 code. Definition of X3 code is a non-weighted self-complement code is called as X3 code. Conversion rule. Decimal digit plus 3 is converted to binary. Here X3 code is obtained by adding decimal number 3 in binary form to the binary numbers in. For example, decimal number 2 is obtained X3 code by adding plus 3. In binary system, decimal number 2 is represented as 0, 0, 1, 0 and 3 is represented as 0, 0, 1, 1. Here we get addition. So X3 code is as 0, 1, 0, 1. Applications of X3 code. It detects the error in digital systems. Here further examples of X3 code as here decimal number 6 is obtained X3 code by adding plus 3. Here 0110 plus 0011 is represented in binary numbers. By adding these we get 1011 and 2 plus 3. By adding these numbers in binary numbers we get 0101 in binary system. Here 7 plus 3 is equal to 0111 plus 0011 is equal to 1011. By obtaining X3 code we add plus 3 to the binary number. Here the information about the X3 code. X3 code table. Decimal binary X3. Here BCD 8421 is represented as 8421. Here numbers 0010. By observing this table X3 code, by adding plus 3 to this all binary numbers we get X3 code. By adding 3 we get 3. By adding 3 to this one we getting 4. By adding 3 to this 2 we getting 5. By adding 3 plus 3 we getting 6. By adding 4 plus 3 we get 7. By adding 5 plus 3 we get 8. By adding 6 plus 3 we get 9. By adding 7 plus 3 we get 10. By adding 8 plus 3 we get 11. By adding 9 plus 3 we get 12 in decimal. Error detection codes. The need of error detection codes. The need of error detection codes to ensure reliable communication in noisy channels. Methods to detect errors. Here methods, there are three methods. Parity bits. There are even or odd. Checksums. Cyclic redundancy checker. Here parity bits. We discuss about parity bits. What is a parity bit? A parity bit is a simple error detecting code used in digital communication. It is an extra bit added to a group of data bits like 7 or 8 bits. Purpose to add to check whether the data was transmitted or stored without error. There are two types of parity bits, one even parity and another one is odd parity. Here even parity is represented as the parity bit is chosen so that the total number of ones become even. For example, data is equal to 1010001, 3 ones. So it means odd. Parity bit by adding 1 we get even parity. Now there are 4 ones. So even parity we obtained. Sent data is by adding parity bit 1 we obtain the data as 1010011. This is about the even parity. Odd parity. The parity bit is chosen so that the total number of ones becomes odd. For example, we have the data 1010001. 3 ones odd. Parity bit is 0 because there are 3 odd ones. So we no need to add parity bit 1. So we add parity bit 0. Still 3 ones. So we get odd parity. So sender data is 1010010. How it is works as sender adds a parity bit to the message before transmission. Receiver counts the number of ones including parity bit. If parity condition is satisfied, even or odd as agreed, message is assumed correct. If not, an error is detected. We focus on parity bits, simple and widely used. Diagram for parity bit. This is the brief diagram about the parity bit. So these are the information of error detection codes and parity bits. Here parity check example. Given data, even parity and odd parity. Here two example. Here given data is 1011. Here even parity 1011. There are even numbers of ones. So this is called even parity. In odd parity 10110. There are odd numbers of 1. So it satisfies the even parity and odd parity. Here 1100. So by obtaining even parity. So even parity is 11001. Here even number of zeros and 1100. Here even odd number of zeros. So it satisfies the even parity and odd parity. Even parity. So further information is about even parity is add bit to make total ones count even. Odd parity. Add bit to make total ones count odd. Here limitation detects only odd number of errors. This is about parity check example. Here the conclusion. Conclusion about binary code. It is a fundamental digital representation. Gray code reduces transition errors. XS3 code self-complementing. Used in arithmetic error detection codes increase reliability in communication. Applications of these codes are used in computers, communication system, digital electronics. Thank you.